All right, last section in Unit 6 is trigonometric modeling. And so it's just like it sounds. We're basically going to be writing equations, sinusoidal equations, for situations where periodic behavior is the norm. So just to remind you, these are the functions we're looking at. F of x equals a sine b, x minus c plus d, or f of x equals cosine. Same things. All right. So what I've done is I've done my best to kind of break it up into its pieces. So what we need to know from the problem is we need to know these three things: min value, max value, and the period of the function. And then for some of these, for all of these, it's really going to help to sketch the graph. All right. Once we have that, we can identify the a, b, c, and d and plug it into one of our two trig functions. All right, so as I'm reading through this, tide behavior is always sinusoidal because we have a high tide and we have a low tide, and of course we have sea level. All right, so coastal areas experience tides, blah, blah, blah. Tides can be mono, okay. At one beach, the high tide is 7 feet above the mean sea level, and low tide is 7 feet below the mean sea level. So that means I have my minimum is -7. This is 7 feet below sea level, which is 0. And the max value is 7 feet above. The length of time between the high and low tide is 7.5 hours. All right, what this does not give me is a period. So I'm going to sketch this graph. Okay, I know I go as low as -7 and as high as +7. All right, I know the length of time between high and low is 7.5, but I'm going to show you how I get the period from that. So high tide is at time equals 0 hours. All right, I don't know this time spread yet, but I do know, so high, I'm going to have a mid, low, mid, high. All right, so this is a mid right here. I don't know, that's at sea level. And my low is here. Well, I know the distance between these 2 points, between high and low, is 7.5, which means the distance between the low and the high is also 7.5. When we did graphing sine and cosine and we did the trigonometric equations, I told you high to high, low to low, or 3 mids. I have 2 highs right here. High to high, I want this distance. All right, well, high to low is 7.5, low to high is 7.5, which means that total distance is 15 hours. All right, so amplitude, max, minus, min, divided by 2. Amplitude is 7. B, 2 pi divided by period. The C, ideally you're looking for a high or a low. I have a very clear high at 0. And the D is max plus min divided by 2. And then we model it. Only they're using t's instead of x's. So h of t, which means the height as time goes by, equals the amplitude, 7. I used a high, so cosine. B, okay, I didn't have a phase shift, so I don't have anything inside here with a t. I also don't have a midline, so my midline is 0. This is my function. Temperature is a really common one for trigonometric modeling because temperatures rise and fall throughout the day, right? So I need a minimum temperature, maximum temperature, and a period. So suppose you know the temperature varies between 58 degrees and 82 degrees during the day. So it means we have a minimum of 58 degrees and a maximum of 82 degrees. It also tells you the period in there because this is over a day. So the period is 24 hours. All right, I can find the amplitude pretty easy. Max minus min divided by 2. So max 82 minus 58. It's 24. Divided by 2 is 12. I can find the b pretty easily because that's 2 pi divided by the period. And I can find the midline pretty easily. That is max plus min divided by 2. What I need is the phase shift. All right, so as I read through this problem, it says the average daily temperature first occurs at 8 a.m. The average daily temperature is the midline. So that is a mid. I'm going to sketch this graph. Sure. All right, your drawing doesn't have to be to scale, so I'm going to put the 58 like right here. And 82, I don't know where my head was, right there. And the midline there. All right, so the first thing I know is that it hits the daily temperature, the average temperature at 8 a.m. So I'm just going to draw an 8 a.m. right here. Okay, and I'm hitting that mid. All right, well, the period is 24 hours. All right, so one full day from 8 a.m. is another 8 a.m. Okay, well, half of that is an 8 p.m. Okay, these are 3 mids. Great. Okay, from 8 a.m. to 8 p.m., okay, halfway between, I should hit a high because that's afternoon, right? So what is halfway between 8 a.m. and 8 p.m.? Okay, that's 12 hours. Half of 12 is 6. So 8 a.m. plus 6 hours is 2 p.m. That's where I'm going to hit the high. And then halfway between 8 p.m. and 8 a.m. is 2 a.m. And that's where I'm going to hit the low. Okay, that means I can also go backwards a little bit and do 2 a.m. over here. Okay, so with the information that we knew was that it was 70 degrees average at 8 a.m. Temperature rises, falls, rises. All right, I have a very clear mid right here. And that mid is at 8 a.m. And that mid is followed immediately by a high. So my graph, my function is a cosine, or a sine, excuse me. All right, so amplitude 12, sine pi over 12, time minus 8, because I'm shifting it over to the right, 8 units, plus 70. Which is all well and good, perfect, but it asks, when does the temperature first reach 64 degrees? Sorry about my dog. 64 is somewhere between 58 and 70 degrees. So I'm somewhere in here. And it's asking when it first hits that temperature. So I want that time. All right, I want that time right there. All right, since I don't know that time, I know the temperature. I don't know, I used H or T. T. I know the temperature there is 64 degrees. I'm going to use that to solve for this. I'm going to use that to solve for time. Right, that means I'm going to subtract 70 first. I'm going to divide by the 12. Now, to get this stuff out of the argument for sine, I need to take the inverse. So inverse sine of negative 1/2. So it's going to cancel this. All right, next thing I want to do is get rid of that pi over 12. So I'm going to multiply by 12 over pi. Multiplying by the reciprocal. All right, so then to finish solving for time, I'm going to add 8. So time equals 12 over pi times the inverse sine, negative 1/2 plus 8. All right, that is 100% in your calculator because of that 12 over pi. All right, so I'm going to show you on the big calculator. Use my 84. All right, so 12 over, pi times, I don't know what mode I'm in. I am in radians, okay. Inverse sine, negative 1/2. Watch all your parentheses here. I went ahead and put that in the calculator, plus enter, and then added 8. So 6 a.m. So at 6 a.m., that's the time when the temperature first hits 64 degrees. The hardest part, unfortunately, it's going to be the algebra here, because you have to figure out how to get that t out of the argument. We subtracted 70, divided by 12, took the inverse sign. Okay, so the inverse sign cancels this. Multiply by 12 over pi, that's going to get rid of the pi over 12. And then added 8. All right, the last type that you're going to see is Ferris wheels. Ferris wheels, because you start low, you rotate around, you get high, you go high, sorry, and you go back low. So we have a Ferris wheel. All right, we start at this point, that's our loading dock. Then we go up to the high point, and then we start going low, and that pattern repeats. Sinusoidal, we go up, and then down, and then up, and then down. All right, so a Ferris wheel is 45 meters in diameter. So this distance, 45 meters. And you're boarded from a platform that is 1 meter above ground. So this distance is 1 meter. Hey, it says the 6 o'clock time, so directly above is level with the loading platform. So these are vertical together. The wheel completes 1 full revolution in 4 minutes. How many minutes of the ride are spent higher than 38 meters above the ground? Get your answer correct to the nearest second. All right, so I need a max value. I mean a min value and a max value. So once you're on the roller coaster, at a minimum, you are 1 meter above the ground. Okay, my max, I'm already at 1. So I'm going to go 45 meters higher than that. So my max is 46. And the period says completes 1 full revolution in 4 minutes. Period is 4. All right, so I'm going to sketch this graph. 46. And let's see, it takes 4 minutes to get through a full thing. So then half of that would be 2 minutes. That's 1. And that's 3. Okay, amplitude. Max minus min divided by 2. So that's 45 divided by 2. And I already forgot what that was. I think it's 22.5. What the heck? I just tried to graph something. Quit. Oh, dang. 45 divided by 2. Yeah, 22.5. The b is 2 pi divided by the period. C we'll get there in a minute. And then the midline, divided by 2. $23.5. So the middle, 23.5. Now, if you're getting on this ride, you're at the lowest point. Okay, if I follow the pattern, at 1 minute we're midline, 2 minutes we're at maximum, 3 minutes we're back to mid, and 4 minutes we're back to low. Okay, so height as a function of time is talking about a height of a Ferris wheel. Amplitude, 22.5. I did forget to get the C. I have a very clear low point right here, 0. But since that's a low, my amplitude will be negative because cosine should start, which is where I'm going with this, cosine starts high. Cosine, pi over 2t plus 23.5. Got my equation. Now it's asking how many minutes of the ride are higher than 38 meters. I don't know what 38 meters is. Let's say it's right here. So right there and right there. So we're looking for this distance. Actually, we're not looking for that distance. We're looking for this distance. How much time is spent above 38 meters? So when I solve this, I'm going to be able to solve for the first instant. All right, so just like I did for the temperature, I'm going to do for the Ferris wheel. Okay, so my height is 38. Now, I'm not going to simplify any of this. I'm going to leave it completely unsimplified because it's going to make your life a little bit better. I'm just trying to use crappy decimals. So the first thing I'm doing is subtracting the 23.5. Interesting. Sorry, I did my own work, my practice problem wrong. So subtracting, so it's 14.5. I'm going to divide, but I'm not going to simplify it. So I'm just going to leave it as 14.5 over negative 22.5. All right, let's see. Now I'm going to take the inverse cosine because I want to get the pi over 2t out. So inverse cosine. All right, and then I'm going to multiply by the reciprocal of pi over 2, which is 2 over pi. So that's going to give me the first instance where the height in the ride is 38 meters. So I'm going to do that in the calculator. Over pi inverse cosine 5 over negative 22.5. Okay, 1.446. Okay, so this time right here, 1.446. All right, well, we have to remember that this time right here is 2 minutes. Well, this is congruent. What I have on the left, I have on the right. So I'm going to find this distance. All right, so minus 1.446. Now I'm going to be accurate, so I'm going to use the answer button, so second negative sign. So it was 0.554. So this distance, 0.554, which means this distance is 0.554. So to get that location, I'm going to take the 2 and add the 0.554. So answer, oops. So an answer plus 2. I don't know why I did that, 2.554. All right, so I have the 2 locations. Once at 1.446 and the second time at 2.554. Great. I just want to know how long I'm above. Well, I did all that work, and shoot, all I needed was this. I have 2 of them. All right, so I'm going to add them together. Okay, so I'm going to highlight it, and times, not decimal, 2. 1.108. All right, now this was specific to the nearest second. So I have 1 minute, so I have 60 seconds already. All right, so now I'm going to do 0.108 times 60. And then answer times 60, 6.501. All right, add those together, I get 66.501 seconds. So it's going to be 67 seconds.